Okay. When you use substitution with a definite integral, I strongly suggest that you don't go back to the original function, because what we've noticed, hopefully, is when we get it in terms of a u, isn't it a simpler function to evaluate? Isn't u to the third over 3 seems simpler than this? Yeah. And so if we have a definite integral that's simpler numbers we're going to have to plug values in, we would rather use that, okay? So what we're going to do is we're going to rewrite our integral, and then we're going to actually rewrite the endpoints of the integral. So I'll show you what I mean by that. So we're going to write from 0 to pi thirds cosine to the fourth of x times sine of x dx. Okay, so first of all, let's see how we're doing with this. What do you think you're going to pick for u? And then what do you think you're going to pick? Well, then what would du be? Negative sine of x dx. So I just see sine x dx. It's going to be -1 or negative du equals sine x dx. Because this is to the, you couldn't do cosine, you have cosine to the fourth. Oh. Cosine is raised to the fourth.
So whatever one has power basically.
Or whatever one is least simple. Okay. You know, because you have both cosine and sine, and you're right, one of the derivatives is the other. But yeah, if it has the power with this, that's the one I want to substitute for, because then I can integrate that as a u. Okay? All right, so now, when I rewrite this, though, I am going to also want to figure out what u of pi thirds is and u of 0 is, because that's going to become my new endpoint. So that's the only new thing with definite integrals. What's u of pi thirds? That means what's the cosine of pi thirds? No. What's u of 0? Guys, unit circle. Alright, so I am going to rewrite this. This is the integral from 1/2 1. We'll talk about that in a second. U to the fourth. For sine x dx, I'm going to write negative du. Yep. See how I rewrote those? Yeah. So I'm going to integrate them and use 1/2 and 1. Yeah. Okay? Oh, you can. So that would be, she said you can. So you see how this is smaller than that?
Right.
She's saying we should flip that around, right? Wouldn't that make it the positive integral from 1 to 1/2? U to the fourth du. Good call. All right, so now we're going to integrate and plug things in. This was u to the fifth over 5, and we're going to, I know it was plus c, but we're going to do this. All right, here's where I'm going to stop you. I did try to tell my kids last year, and some of them wanted to go back. They wanted to go back and put it in and then put pi thirds. Guys, that's so much more work. I can just now use this. This is way easier. Because this is 1 to the fifth over 5, right? This is 1/5. And then this is 1/2 to the fifth over 5. Is it 1/2 to the fifth over 5 the same as 1/2 to the fifth times 1/5? Alrighty. Let's do some work here. Let's see. 1/2 to the fifth is 1/5. 2 to the fifth is 32, right? 32 times 5. Yeah, let's just do it. 10, 160. Alright, so this is minus 1 over 160. What? Right. Dividing by 5 is the same as multiplying by the reciprocal, which is 1/5.
The reciprocal, but, okay, yep, got you. Instead of putting 1/2 over 5.
Yeah. Alright. Hey, I just did this. Isn't 5 times 32 160? So this is the same as if I multiplied top and bottom by 32. This is 32 over 160 minus 1 over 160, 31 over 160. No. Okay. So my advice to you is this. If you are using use substitution on a definite integral, do the work on the front end. Rewrite it as an integral and change the endpoints, because the substitution is going to, in my opinion, is going to be easier to do that way, evaluating, than having to go back and then plug in the pi thirds and the 0 and all that. Okay? Both ways will give you the correct answer, if you do them correctly. Alright. Questions so far? Alrighty.